Hi, my name's Aaron. I am a localization engineer at Lingua Maven, and we help engineers, engineering teams to learn the best practices around how to internationalize their code bases. But today, I want to show you a quick demo on counting strings. So as you can see, I have a really simple script here, assigning a string to example, returning the length. There's really not going to be anything too earth-shattering here. It has a length of 2 because there's 2 letters. Okay, makes sense. But what happens if we add just one emoji? Let's use the hand wave emoji. Okay, it's still outputting 2, which might not be what you expect because it's just one emoji, but it's outputting 2. Okay, let's do a little bit more exploration here. Instead of just the default hand wave emoji, what if we use emoji with my skin tone, which is as pale as they come? And now, what is our length? It's 4. Okay, so this is demonstrating one of the most common bugs I come across whenever I help teams internationalize their code, and it really happens in any code base, is that the length isn't always what you might expect. It's not counting visible characters. So let's do a bit more deep diving. How about we, instead of outputting the length this way, let's just spread it into an array and see what happens. Okay, so it's outputting the default wave emoji and then this modifier character for the light skin tone. That makes sense, but that doesn't really explain where our length of 4 is coming from. A good way to check that is let's just do a for loop. So I'm going to make a normal for loop. I'm going to be terrible at typing since all of you are watching me. And now I'm going to output example at x. So what will happen here is that it's going to output 4 lines. So we know that that's our length of 4, but it's outputting this corrupt character icon. This might look familiar to some of you if you deal with string corruption sometimes. A good way to see the actual value of this line is instead of using x in this way, we're going to use this function called character code at, and we'll output that at x. Okay, so it's outputting these numbers. This is really the biggest lesson, is that length in programming language does not count visible characters as you and I would define them. What they're counting is code units. And a single string can have a different number of code units depending on what kind of encoding your string is using. JavaScript by default uses UTF-16. This length would be different if we used UTF-8. And I just so happen to have some code ready to go, and we will replace that. Okay, so this is taking the same exact hand wave emoji with the light skin tone, and it's outputting the length as UTF-16, which in JavaScript doesn't take any modifications because it uses UTF-16 by default. And now it's taking, on line 4, it's taking that exact same string, encoding it as UTF-8, and then outputting that length. So whenever we do that, you see that it has a length of 4 in UTF-16, and then it has double that in UTF-8. So this is something that's really important to know, is that the length can change depending on your encoding. And this really messes a lot of teams up, and it takes a lot of teams a long time to figure out why in the world their length is changing or why they're having some corrupt characters. So let's think of how this actually affects us in our day-to-day lives as we're working on a code base. So let's say we have a user and they have the ability to set their own bio. In my example here, I say, hi, I like peach pie and I live in Portland, Oregon. And then your design team says, hey, we need to take just the first 25 characters of the user's bio, and we want to output it and maybe add an ellipse to it, do something to it. So, okay, easy enough. I'll just use a substring and cool, good to go, feature done, ship it. But now let's say the user at some other time wants to add a little bit of personality. to their bio, and they use the peach emoji. Now, whenever we output this, it's showing a corrupt character. But why would that be? Well, it just so happens in this example that the peach emoji has a length of 2. So that means it has 2 code units, and it happens to land on the 25th and the 26th element of this string. And so by doing a bio.substring here of 0 to 25, you're only capturing the first code unit of the peach and not the second. And whenever you output that, it has a dangling code unit, and so it doesn't really know what to do with it. Therefore, you get the corrupt string. So how do you prevent this? It really changes depending on what programming language you're using. The kind of terms you'd want to look for are Grapheme or Grapheme clusters, multibyte strings, and you want to look up your programming language's best approaches to splitting them up while considering the multibyte string characters. I happen to know in JavaScript, a good way around it in this scenario is by casting it as an array. So I'm going to do the spread operator. And in JavaScript, this spread operator pays attention to multibyte strings or Grapheme clusters, and it will be less likely to split up those code units whenever they shouldn't be. So now I have bio as an array, and then I'm going to get the first 25 elements of that array, and then now I have to turn it back into a string, so I'm going to join it by an empty string. And now, whenever I show my truncated bio, it doesn't split up the peach code units. And so that prevents the corrupt characters in JavaScript specifically. There's probably a library in your package manager of choice that will help you with this, but it's just really important to every time you're referencing a string and you're only getting a subset of that string, that it is not getting visible characters as you and I might define it, but it is getting code units. And this doesn't only apply in programming languages, but also if you have a database field and you say, I want a max of 100 characters in that field, that's not 100 visible characters, that's 100 code units. And so make sure to check the documentation of your database of choice and make sure that you understand exactly where it will cut off, because it will probably be cutting off at a code unit. And if you have any other translations, or you're using characters that have a higher code unit of more than one, or you're using a different character encoding, that could cut off the code units and create a corrupt character. So I hope you found this useful. This is just a really quick example of one of the most common issues I come across whenever teams are wanting to update their code base or dealing with corrupt strings. If you find this useful, feel free to reach out. I'll have my contact info in the description. And yeah, good luck with dealing with strings in your code bases.